If a segment that connects the midpoints of two adjacent sides of a rectangle has a length of 5, as shown, what is the sum of the squares of the lengths of all four sides of the rectangle? Well, let's draw a diagram and then let's work from there. So let me just sketch this. So they're saying that the midpoints of the two sides, so here's the first midpoint and approximately there's the midpoint of the other side, and there's the connection. So let's label this now. From here to here I'll call x, from here to here is x since that was the midpoint, and I'll call this y and that y. Now this is a rectangle, so that means that's a right angle, and therefore that triangle forms a Pythagorean relationship, which in this case is x squared plus y squared is equal to 5 squared, since that, as you can see up here, has been labeled as 5. Okay, so that's the first part of the setup of the question. Now, the next part is, what is the sum of the squares of the lengths of all four sides? The sum of the squares. Okay, so this side is 2x and this side is 2y. So the sum of the squares of the lengths of all four sides. So that would basically be 2y squared plus 2x squared, but they want all four sides, so another 2y squared and another 2x squared. So I'm pretty sure that is what they're asking. Just got to make sure you read the question carefully. Okay, so now if I do this math, it'll be 4y squared plus 4x squared plus 4y squared plus 4x squared, and then if I add it all up, it will be 8x squared plus 8y squared. Factor out an 8 and we get x squared plus y squared. Well, the good news is, in the first part of the question, we had already figured out what is x squared plus y squared equal to. It's 5 is equal to 5 squared. So just substitute that in. And then we have 8 times 25, and that is 200. 200 is the answer to the first question. Neither of two different positive integers is a perfect square, but their product is. What is the least possible value of this product? So they're saying you've got two numbers and neither of them are perfect squares. So let's say the first one is a and it's not a perfect square, and the second one is also not a perfect square. Okay, I don't know how that helps, but that's just sort of a mathematical way of describing it. Okay, so then they're saying when you do the product of these two, it does become some perfect square. Okay, and then they're saying what is the least possible value of this product? So what is basically what is k squared? Okay, so I guess this is just a bunch of trial and error, I think. Okay, let me think about this. Let's start with a. If a, well, if a is 1, that's already a perfect square because 1 is technically 1 squared. So how about if a is 2? Okay, 2 qualifies, so let's try a as 2. Then to make a times b a perfect square, what could b be? 1, 2 times 2, but but they're different though. So a cannot be 2. I almost thought I was done. 3, but 3 times 2 would be 6. 4 is a perfect square. 5, 2 times 5 would be 10. 6, 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 16 works. So if b is 8 and b is not a perfect square, a is not a perfect square, but then ab would be 2 times 8, which is 16, which is 4 squared. There you go. So I guess the answer to this question is 16. So it was basically just trial and error. What is the least possible sum of 3 positive integers in the ratio half to a third to a quarter? Okay, so we have half to a third to a quarter. And the first thing I want to do is multiply through, so I get rid of these fractions. Multiply through by 24. And when I do that, I will get 12 to 8 to 6, I believe, right? Yeah. What is the least possible sum? Well, this sum, if the numbers are 12, 8, and 6, would be 26. But they want the least possible. And I see this can actually be further decrease down to 6, 4, and 3. That's also the same ratio. And if those are the numbers, then it would be 13. So 13 is the least. And I don't think it can be reduced even further because and it remain as integers. Yeah, that's the key word there. A man bought 25 bottles of milk for 30 cents per bottle. He diluted the milk by adding 1 bottle of free water, and then he sold all 26 bottles of the resulting mixture for 40 cents per bottle. And then what is the percentage? What percent of the man's profit on the sale of these 26 bottles was attributable to the water, not the milk? All right, so, oh boy, let's think about this for a second. So he bought, let's see, how much did he buy? He bought 25 bottles of milk at 30 cents per bottle, correct? So he spent $7.50. Yeah. And then he sold 26 bottles at 40 cents. So that's $10.40. So if you just look at those two numbers, the profit would be 10.4 minus 7.5, which is 2.9. Okay. So then what are we trying to figure out here? What percentage of the man's profit was the sale of the 26 bottles was attributable to the water? Ah, okay, I got it. So, well, the profit is 2.9. That's what we figured out. And then the water is basically all they're interested in. The water is 1 bottle. And he sold 1 bottle for 40 cents. So that would be the profit just for the water. So this is basically the math. And then this is about 13.79. I'm not entirely sure how many percentage points. Decimal points, that's what I meant to say. But I think 2 decimal points should be sufficient. A sequence of terms is formed by following the 2 rules below. If a term is even, divide by 2 to get the next term. If a term is odd, multiply by 3, then add 1 to get the next term. When we start with 12, the first 2 terms of the sequence are 12, 6, 3, 10, 5, 16. What is the sum of the sequence's first 2003 terms? Ah, okay. So, well, they gave us the first few, and let's just see if we can get a few more. So, we're going to be, of course, following those 2 rules. So, the next term we will get by using the 16. If a term is even, we divide by 2. Okay, so the next term would be 8. That was this first rule. It's even again, so divide by 2. It's even again, so divide by 2. It's even again. Now we get to the 1. So we have to use this one. If a term is odd, multiply by 3, then add 1. So 1 multiplied by 3 is 3, add 1. So we get a 4, if I've done this correctly. And then this is even, so you use rule number 1 to get a 2. Then rule number 1 again to get a 1. And then we get 1 again. So then we use the second rule. Multiply by 3, and then add 1, so that would be 4. And then a 2. Okay, so it repeats. You see how it's going to repeat 1, 4, 2, 1, 4, 2, and so on. Okay, so then we want the first 3 here. Ooh, okay, so I got to extrapolate here. Let me think about this, actually. So 1, 2, 3, 4, 5, 6, 7, 8. So these are the first 9 terms. And then this is until term 12. And then this is until term 15. And then it kind of just goes on like that. So if we keep adding 3s to 15, we will eventually get sufficiently close to 2003. And then, so if we get up to 1995, well, again, we'll have the 1, the 4, the 2. And then the next 3 terms will be a 1, a 4, a 2. And then the next 3 terms goes to 2001, which will be a 1, a 4, and a 2. And then the 2002 term is a 1. The 2003 term is a 4. You got it? So I got to add all these up because they want the sum. Okay, so that's going to be 66 for these guys. And then this is a 7. And then there's a whole bunch of them. a whole bunch of them. And if you add them all up, there's 664 of those groups of 3s, and each of them has a sum of 7. And then don't forget the very last 2 add up to 5, and that's the sum. So that is 4719. No pair of integers xy, neither of which is negative, can satisfy 9x plus 16y is 78. What is the largest integer n for which no pair of integers? All right, so I'll explain this. So basically what we want 9x plus 16y is n. To concentrate on this equation first of all, and then we kind of go from there. So what is this question really asking is to concentrate on this equation, but in particular look at what is the largest possible value of n. They've given us one such example, but obviously I'm assuming 78 is not the largest. So this table is sort of at the heart of the solution. What you do is you take this equation and you will, if you look at this table, the ones that are not shaded, so the 1, the 2, the 3, and so on until 8, those are the ones that there is no solution for. So for example, if you said 9x plus 16y is equal to 4, there's no integer solutions. So that's why they are shaded. Not shaded, they're white. But if you look at this one right here, the one that's a 9, that is shaded because there is a solution for that. So there's a solution when x is 1 and y is 0. So the ones for which there is a solution, it's shaded. So we want to keep going and shade anything that there's a solution for. And eventually you'll see that after a certain time everything will be shaded because there's a solution for every number. So what they're saying is, what is the largest number for which there is not a solution for? And if you keep following this table, you will eventually see the 78, which is right there, which is the one that they initially gave you that there is no solution for. And then eventually you'll get to 119, which is the largest value for which there is no integer solution for this equation. So the answer to this question is 119.